In this question, we have to integrate our fx from 1 to k, where your fx is 2x plus 8 when x is between 1 to 2 and 6x when your x is between 2 to k. Let's draw a number line to represent our function. Our changing point is 2. So let's plot 2. 1 will be on left side and k will be on right side. Now, as we know, between 1 to 2, your function must be 2x plus 8. And between 2 to k, your function must be 6k. So we have to split our integration from 1 to 2 plus from 2 to k. Now, between 1 to 2, your function must be 2x plus 8. And between 2 to k, your function must be 6x. Now we are ready to integrate. Integration of 2x will be x square by 2 plus integration of 8 will be 8x. Your limit is from 1 to 2 plus integration of 6x will be 6 as it is. Integration of x will be x square by 2 and your limit is from 2 to k. Now let's simplify. This 2 will cancel out. If we substitute upper limit, we will get 2 square, or we can say 4 plus 16 minus, if we substitute lower limit, we will get 1 square plus 8. Similarly, here we will get 2 3s are 6. Your upper limit will give us k square minus your lower limit will give us 4. Now, it is given that your integration's answer will be 47. So, let's substitute 47 instead of I. So, here we get 47 is equal to 4 plus 16, or we can say 20, minus 8 plus 1, or we can say 9. 3k square minus 12. So, we'll get minus 1 plus 3k square, or we can say your 3k square must be 48, which will give us k is equal to plus 4 or minus 4. But our limit is from 1 to higher value. Then and then your 2 will be intermediate term. K or k equal to 4 must be greater than 1. Then and then your 2 will be intermediate term. So k equal to 4 is your final answer, and k is equal to minus 4 is less than 1, which not satisfied the condition. So option A is the final answer. Ta-da! In this question, you have to integrate mode sine 2 pi x from 0 to 1. Here, within the mode, we have sine 2 pi x. And let's check the changing point of the function by taking function equal to 0. Your sine will be 0 at 0, pi, 2 pi and dot dot dot. So we will get x is equal to 0, 1 by 2, 1, dot dot. But our changing term should be belongs to 0 to 1. We can accept 1 by 2 as a changing term. So let's plot on a number line. So we can say for first interval, or we can say from 0 to pi 1 by 2, your fx will be positive. So it will be sine 2 pi x. And between 1 by 2 to 1, your function will be negative. So it will be minus sine 2 pi x. So let's split our integration into 0 to 1 by 2 and 1 by 2 to 1. Between 0 to 1 by 2, your function will be sine 2 pi x. And between 1 by 2 to 1, your function will be minus sine 2 pi x dot dx. So, integration of sine 2 pi x will be minus cos 2 pi x upon coefficient of x, which is 2 pi, plus integration of minus sin 2 pi x will be cos 2 pi x upon coefficient of x, which is again 2 pi. The limit of the first term is 0 to 1 by 2 and 1 by 2 to 1. So, if we substitute upper limit, we will get minus cos pi plus your lower limit will give us cos 0 whole divided by 2 pi plus from upper limit we will get cos 2 pi minus from lower limit we will get cos pi upon 2 pi. So minus cos pi will be 1, cos 0 is also 1 upon 2 pi plus cos 2 pi will be 1 and cos pi will be minus 1. So it will also become 1 divided by 2 pi. So here we'll get 1 by pi plus 1 by pi, or we can 2 by pi is your final answer, which is given in option D. Ta-da! If f is an odd function, then integration of minus a to a is 2 times integration of fx from 0 to a. It is the property of definite integral. So, ta-da! Here we have to integrate sec 2x minus 1 upon sec 2x plus 1. To simplify, let's convert sec into 1 upon cos 2x. So we will get 1 upon cos 2x minus 1 upon 1 upon cos 2x plus 1. If we take the LCM, we will get 1 minus cos 2x upon 1 plus cos 2x. And we know that 1 minus cos 2x upon 1 plus cos 2x is actually 10 square x. And to integrate 10 square x, we have to convert into 6 square x minus 1. So we are ready to integrate. Integration of sec square x is simply 10x, and integration of 1 is x plus c is your final answer, which is given in option B. Ta-da! Here it is given that integration of fx is equal to log x raised to 5 upon 5 plus c, and we need to get your fx, which is within the integration. So to remove this integration, let's differentiate both the sides. So we can say fx is simply differentiation of our right hand side. In right hand side, your log x is inner function and 1 by 5 is constant, so we don't have to worry about it. Let's differentiate box raised to 5, 5 box raised to 4 into d by dx of your box. Within the box, we have log x, so we have to differentiate log x, which is 1 by x, and differentiation of c, which is constant, will be 0. So here your fx will be, this 5 will cancel out, and we will get log x raised to 4 upon x, which is given in option B. Ta-da! Here it is given that integration of function is equal to itself, and this condition is satisfied by only one function, which is e raised to x. And we have to find integration of fx the whole square, or we can say integration of x the whole square, or we can say e raised to x the whole square is actually e raised to 2x. Integration of e raised to 2x is e raised to 2x upon coefficient of x, which is 2, plus c. But our answer should be in terms of fx. So we can say e raised to 2x should be rewritten as e raised to x the whole square plus 2. So here we get fx the whole square by 2 plus c as a final answer, which is given in option A. Ta-da! In this question, we have to integrate x upon 1 minus x cot x. For simplification, let's replace our cot x by cos x upon sin x. So if we take a LCM, here sin x will multiply with 1 and we will get sin x minus x cos x upon sin x. But here sin x is denominator of the denominator, so it will move in numerator. So finally we will get x sin x upon sin x minus x cos x. Actually, your numerator is differentiation of denominator. Let me show you how. By taking differentiation of your denominator, which is sin x minus x cos x. The differentiation of sin x is cos x minus x as it is. Differentiation of sin x will be minus sin x plus cos x will be as it is. Differentiation of x will be 1. So your cos x will cancel out and we will get x sin x, which is given in numerator. So in numerator we have f plus x and in denominator we have fx. So its integration will be log more denominator, which is sin x minus x cos x plus c, which is given in option C. Ta-da! આ પેલું ટેક્સ્ટ બુક નો જ સમજે. x plus 1 upon under root of x square plus 1 હોય. નીચેનું ડિફરન્શિએશન ઉપર સેટ કરવા માટે આપણે શું કરવાનું? 1 upon under root of x square plus 1 કરી નાખવાનું. પછી હા x square plus 1 ને t સપોઝ ના જો આપણે ફિઝિક્સ આપણે શું કહેવાય શોર્ટકટ મેથડ યુઝ કરી જ શકીએ છીએ. આને fx raised to -1/2 લઈ લઈએ અને f dash x છે તો +1 કરો તો શું થાય? raised to 1/2 upon 1/2 થાય અને આ થાય log more x plus under root of x square plus 1. ખ્યાલ આ પણ ટેક્સ્ટ બુક tan inverse x square નું નીચે 1 upon 1 plus x થીટા tan inverse x square છે અને બીજું બધું 2x upon 1 plus x raised to 4 છે. તો આ શું છે? fx અને f dash x છે તો raised to 1 છે તો શું થઈ જાય? tan inverse of x square whole raised to 2/2 plus c. તો કયો આન્સર આવશે? b. m અને n લેવા હા sin raised to 0x. યસ એટલે m આપણે cos x આવે તો sin x equal to t લેતા હતા તો cos x dx will become dt. So cos raised to 4x actually split into cos raised to 4, which will become 1 minus sin square x, the whole square, and 1 power of cos x will go with the dx. So here we'll get 1 minus t square, the whole square, and this will become dt. ખ્યાલ આવ્યો હેતા? Yes. પછી આપણે સ્પ્લિટ કરી નાખીએ. So 1 નો integration t આ થાય t cube by 3 અને t is to 5/5 plus c. તો આ t શું થશે? sin x sin cube x અને sin x is to 5 प्लस सी છે આવો કોઈ ઓપ્શન cos સ્ક્વેર થી ડિવાઇડ કરી નાખવાનું તો 1 upon cos સ્ક્વેર sec સ્ક્વેર x થઈ જાય and 1 divided by cos square again sec square x થઈ જાય sin square x cos tan square x થઈ જાય યાદ છે આવું કંઈ કરતા હતા હવે આ જે sec square x છે એ tan x નું ડિફરન્શિએશન છે તો પછી આપણે આ tan નીચે sec square x હોય તો ના ચાલે એના બદલે શું લખી નાખવું પડે 1 plus tan square x તો આ tan square x અને tan square x શું થઈ જશે याद नहीं है कहीं हाँ tan x equal to t लो तो sec square x dot dx dt મળે तो आ sec square x dot dx will become your dt and here we get 1 plus 2t square तो आ શું થશે 1 upon root 2 tan inverse of root 2t plus c t ની વેલ્યુ મૂકી દઈએ ખાલી કયો આન્સર આવે
ઓપ્શન A.
In this question, we have to integrate 1 plus tan square x upon 1 minus tan square x. Basically, it is the formula of 1 upon cos double the angle. Or we can say, we have to integrate sec 2x. Integration of sec 2x will be log more tan pi by 4 plus half the angle. Or we can say x plus c and don't forget to divide the coefficient of x which is 2 so 1 by 2 will be as it is to get the answer let's apply the formula of tan alpha plus beta so it will be tan alpha or you can say tan pi by 4 plus tan beta which is tan x upon 1 minus tan alpha tan beta say tan pi by 4 into tan x. Now we know that the value of tan pi by 4 is 1. So we will get log of 1 plus tan x upon 1 minus tan x plus c is your final answer which is given in option D. Ta-da! In this question, you have to integrate sec square 7 minus 4x. Your inner function is 7 minus 4x, which is polynomial of first degree. So let's consider box around it. Integration of sec square box is simply tan box. Within the box, we have 7 minus 4x. So don't forget to divide by coefficient of x, which is minus 4. Plus c. So your final answer is minus 1 by 4 tan 7 minus 4x which is given in option A. Ta-da! In this question, we have to integrate log of sin x into cot x. Basically, cot x is differentiation of log sin x. Let me show you how. If we differentiate log sin x, then we have to consider box around the sin x. So differentiation of log box is simply 1 upon box into d by dx of box. Within the box, we have sin x, so we just have to multiply differentiation of sin x, which is cos x. This cos x upon sin x will simply become cot x. So as you can see, if we consider log sin x as your fx, then its differentiation is available within the multiplication. So to integrate this term, just have to take one extra power. So we get box square upon 2, or we can say log sin x the whole square upon 2 plus c, which is given in option C. Ta-da! In this question, you have to integrate e raised to minus cot inverse x upon 1 plus x square. Here, your inner function is minus cot inverse x and its differentiation is also available within the multiplication of dx. So, let's assume minus cot inverse x is equal to t. Differentiate both the sides, we will get 1 upon 1 plus x square x dot dx is equal to dt. So we can say we just have to integrate e raised to this minus cot inverse x will become your t and dx upon 1 plus x square will become dt. So integration of e raised to t is simply e raised to t plus c. To get the final answer, just substitute the value of t, which is minus cot inverse x, which is given in option A. Ta-da!